Hey guys, in this section, the notes talk you through Descartes' rule of sign to determine positive, real, negative, and complex zeros. That's an older method that we used when you don't have a calculator, but since we all have access to a calculator, I'm going to show you how to do this using the calculator. So I have 3 problems we're going to go through, and I'm going to graph these so I can see what's going on. So, I'm in the scientific. I'm going to go to Desmos. It's my online calculator. And I'm going to enter this function. So 5x to the 5th minus x to the 4th plus 11x squared plus 12x minus 24. Right, and I'm going to come look at this function. What's going on? So I'm going to take a screenshot just because I want to be able to look at it and write on it with you guys so we can analyze what's going on with this function. So this function has one x-intercept. This is considered a real zero. And I'm looking, it's a positive number. So these are on this side of the x-axis, these are positive. So this is a positive real zero. A negative real zero is what it's asking for. How many negative real zeros? That would be anything crossing the x-axis. And we don't have anything crossing over there, right? So this function has one positive real zero, 0 negative real zeros, but our total amount of zeros is 5. So if I have 1 positive and 0 negative real zeros, that means I must have 4 imaginary. And I know this question isn't asking that, but we'll get to some that do. Because we're looking at x-intercepts, okay? So let's go to the next one. This one is asking about imaginary. So how many imaginary zeros does the function have? So again, let's graph it. Negative 4x to the 5th. So this 5, guys, this is how many zeros there are. The highest degree. There's 5 zeros on this function. We just don't know what they are. That's what we're trying to find out. So 3x to the 4th plus 16x minus 31. And again, I just can't write on this. So I'm going to take a screenshot. Just because I'm going to be able to write on here and show you what I'm talking about. So here's this function. And it kind of goes up and down a little bit, as you can see. And we are trying to find out how many imaginary zeros. So I know that there's 5 total because it's a 5th degree polynomial. So I'm going to start looking at my x-axis because that's where my real zeros show up. And I only have one here. So this is a real zero because it crosses the x-axis, and it's negative. It's like negative 2. So right now of these 5, I only have 1. I need 4 more to get to that 5. And there's nothing else that crosses the x-axis. But we do have these twists and turns here. So right here, this bump that counts for 2 imaginary, and this one that goes up and down. It's like a quadratic that counts for 2. Remember when we were graphing with quadratics and they had 2 zeros? So here there's 2, and here there's 2. So we have 1 real and 4. Definitely will not have 0. Again, I'm going to graph these and look at them. So I have x to the 5th minus x to the 4th plus x to the 3rd plus x minus 50. And you can look at the graph if you want to zoom out or zoom in. It definitely has a cubic shape to it because it's a 5th degree. So it kind of curves a little bit. Hold on while I get this into my screen so I can write on it. So here's our graph. It's asking for positive, real, negative, real, and complex. So remember that complex is the same as imaginary, so what we were just looking at. So right here is where I want to start. I always want to start on the x-axis. That's my real zeros. And I just have 1. It's only crossing 1 time. And it's a positive. So I'm going to go back and just check. I have a 5th degree. That means I have 5. So I have 1 positive. So when I'm looking here, I do have 0 negative, right? So 0 negative, that's correct. We have 1 positive. And that only accounts for 1, so that means my other 4 to get to that 5 are complex or imaginary. They're the ones we don't see, but it's actually this curve. So for complex, I don't have 0. Okay, so as you go through these, I would look at the graphs. If you want to use Descartes' rule of sign, you can, but it's definitely easier to just use a graphing calculator. So if you have questions, you can ask me or Ms. Hart.